Hi, I'm Paul Cleary, Ecosystem Architect at Venafi. In this presentation, I'll demonstrate in just a few steps how easy it is to configure Venafi's Vault plugins to get machine identities at the speed that DevOps teams need while providing visibility and the ability for InfoSecurity teams to enforce standard policy on machine identities being issued by Vault. First, we'll take a quick look at what HashiCorp and Venafi are doing together to make the lives of InfoSec and DevOps teams easier. Then we will look a bit closer at the two Vault plugins that Venafi has created before moving into a short demo to see those integrations in action. HashiCorp is a strategic partner of Venafi, and because of that, we have a number of very tightly integrated solutions available for DevOps teams inside an organization. This first one, the Venafi Secrets Engine, allows for publicly trusted certificates to be issued from Vault through Venafi's Trust Protection platform. This Secrets Engine, along with the Monitor Engine, will be the main focus of this presentation. The Venafi Monitor allows DevOps engineers to continue using Vault's built-in certificate authority, but with the added ability for the security team to set policy and gain valuable visibility and intelligence around the machine identities being issued by Vault. Our Terraform provider allows developers to get the machine identities they need as part of their infrastructure build, enabling them to start thinking about the security of their deployments as early as possible. One common function achieved by all these integrations is the ability for Venafi to provide a means to HashiCorp tools to consume publicly trusted certificates. Venafi's view on DevOps is really to help speed up software development by enabling automation for both developers and information security teams. Issuance and installation of machine identities needs to be automated and hooked into DevOps workflows. The Venafi platform empowers InfoSec to deliver a standardized set of consumable services for autonomous application development teams, relieving them of that heavy burden of creating their own security architecture. What this does is enables the DevOps teams to go faster and improves the security posture of the organization as a whole. The biggest change in mindset is that InfoSec can actually help the DevOps teams go faster by reducing the time spent on the machine identity process. With that, let's dig a little bit deeper into the Vault integration. When organizations use Vault and Venafi together, developers are able to focus more of their time on developing applications. The Vault plugins are easy to implement and use, and enforce centralized policy and controls to ensure all requested certificates are compliant with corporate security and audit policies. Developers and security teams have options when it comes to deployment configurations. Dev teams don't have to worry about the underlying security policy. They just continue using development tools that they use every day, in this case Vault, to get the machine identities they need to secure their applications at the speed they require for DevOps practices. The Vault engines are custom secret engines originally sourced from the native PKI secrets engine. So what this does is replace the certificate enrollment functionality so that rather than being issued by a local CA inside of Vault, certificate requests are submitted to and fulfilled by Venafi Trust Protection Platform or Venafi Cloud using the vCert SDK. This addresses some of Vault's shortcomings with centralized management, policy enforcement, visibility, and enables the use of, again, really any certificate authority, including those that are publicly trusted. The Venafi Monitor is also a custom secrets engine developed from the native PKI secrets engine. And with this integration, certificates are still issued by the local CA, ensuring no loss of functionality or performance degradation. But every certificate request is assessed for compliance before being issued with the Venafi policy that has been previously retrieved from the Trust Protection platform and set in place by the security team. Venafi policies can be applied to each PKI role, and they remain in effect until they're retrieved again. Every certificate issued by the local CA using this Monitor plugin can be forwarded to the Trust Protection platform or Venafi Cloud for visibility and auditing purposes. And with that, we will take a look at the integrations in action. All right, so the first thing that I want to show is to get logged into the Venafi Trust Protection platform. And then over on the left here, we have what we call the policy tree. And just want to show real quick the existing policy that we have configured for our HashiCorp Vault demo. And so there's really 3 policy folders that we'll be interacting with for the purposes of this demo. The first one is going to be the Venafi issued policy, since we're using the PKI backend Vault plugin. And if you remember, this is the plugin that's going to allow Vault to submit requests to the Venafi platform and have those requests fulfilled by really any certificate authority that the customer may have configured, including your internal Microsoft PKI or any of the various publicly trusted certificate authorities that we have integrations with. And so if we take a look at this Venafi policy, Venafi issued, I'll click on the certificate tab here, and really I've left a lot of the policy default, so everything is blank. What this means is the end Vault user will be able to specify really anything for these values that they'd like. You do have the ability as a Venafi administrator to come in and set defaults on these policies or lock these policy values so that the end users, if they tried requesting a certificate that hits a locked value, the request would obviously be denied. The only thing that I have set up in this policy is a couple of whitelisted or allowed domains, and we'll demonstrate the functionality of that in just a minute. So I'm going to go ahead and save this policy. I'm going to expand this folder so we can see that there are no certificates currently issued by Vault. And then I'm going to switch over to my demo system here, where we have an instance of Vault running. And the first thing that I want to do is really issue some example certificates, right? And we'll do that, but first maybe let's take a look at what we have in this folder. So you can see that the role that I have configured for this issuer here, it really gives all of the configuration information that is needed to connect to the Venafi instance. So we've specified our user, we have our password saved, and then we've specified the endpoint that we'll use to connect to the Venafi server. And so to issue a request, I've got them all saved, so I'm just going to be copying and pasting, and I'll explain what's happening with them. So we are timing the requests because we're interested to see how long it takes to get the machine identity back once the request goes through. And really, like I said before, we're just supplying the common name of the certificate. Everything else is going to be filled in by the policy that's set forth by Venafi admins. So if we hit enter here, this is going to create the CSR and ship that to Venafi and be fulfilled by our backend certificate authority. And so you can see the time takes about 5 seconds or so. So let's continue requesting just a couple more certificates here. And we should see consistently about 5 seconds or slightly less each time. So that seems to be the trend. And lastly here, we'll try a different domain. We're going to use the Venafi example domain for this example. Okay, and again, that one comes back just around 5 seconds. This time it was just a little bit higher. And so that's a demonstration of an approved request through Vault. If we wanted to take a look at what happens when someone requests a certificate that doesn't conform to that policy that we looked at just a minute ago. So this, you can see I'm requesting a cert for the Google domain, which was not approved in our policy earlier. And so pretty immediately, we should see an error come back. And really it's saying that, hey, this DNS does not match a valid domain for the folder. Okay, and so if for whatever reason this was a unwarranted error, or if the security team really did want a request for google.com domains to be issued, then what we would do is go back to the Venafi system. It's a really simple change to make. We just say, I want google.com to be in my list of allowed domains. Save the policy, and we can make that request again. This time it should go through successfully in about those same 5 seconds. And we see that it does. Okay, great. So we've seen that Vault can issue certificates through Venafi using the configured certificate authority that can either be a publicly trusted certificate authority or an internal Microsoft PKI. Really, again, any certificate authority that integrates with the Venafi platform can be used in this example. And we've seen that those requests using a Microsoft CA take roughly 5 seconds or so. Now, for most use cases in an organization, 5 seconds is a pretty good response time. However, when we start thinking about DevOps pipelines and the tools and really continuous delivery that they're used to, 5 seconds can mean it can be a lifetime. And so we really need to get that issuance time down to sub 1 second times. And the way that we do that is by using the other plugin that I mentioned, the Venafi Monitor plugin. And so for that, I'm just going to clear my screen here. So at this point, remember, the Vault Monitor plugin gives the DevOps teams that speed of issuance that they're used to and allows them to continue using the built-in Vault CA, while still providing InfoSec the ability to set and enforce policy on the machine identity requests that are originating from Vault. And so the first thing that we'll do is take a look at the policy that we have in place for the Vault Monitor. We'll just apply the policy in order to do that. And so you can see that all of these items here are really what's set forth back on the Venafi Vault policy, which we'll take a look at in just a minute. So you can see I've got a couple of domains that are allowed, venafidemo.com and venafi-example.com. We have our available key sizes to use, our key types, and really any of the other policy information that's set forth by the Venafi admins. And so if I take a look at my Vault policy, this is where Vault pulls the policy from. Any certificates that get issued will appear in this Vault issued folder. If we look at the policy here, we see those domains that we just saw from the Vault screen are in our list of allowed domains. So there's really nothing to save at this point. What we need to do is demonstrate really the speed of issuance that you get. And if you are a user of Vault, this should be something that's fairly familiar to you. So for this, I'm going to use the same copy and paste method, but I'll describe here what we're doing. So again, we're going to time these requests because we're interested to see how long they take for the certificate information to get back to the Venafi platform and give the InfoSec team the visibility that they need. So we'll make this request, and as expected, you can see that this is really that sub 1 second issuance time. So we're getting about 0.35 seconds to issue certificates using the Vault CA. And the cool thing is, as soon as these are issued, they are making their way back to the Venafi platform to again give that visibility and intelligence to the security team and make sure that all of the machine identity requests originating from Vault conform to the enterprise security policy. So let's try a couple more requests here. We'll do that one again, very quick issuance time, and then we'll try one more here that we know should be a successful request. Again, 0.37 seconds. So they're really getting that instantaneous issuance speed that they need. Similarly, if we make a request that doesn't conform to the policy, for this example, I'm going to use newdomain.com, we'll get a similar error message that we saw before, right? This common name, app8 newdomain.com, doesn't match our allowed domains, venafidemo.com or venafixample.com. And so in order to make this change, what we're going to do is go back to the Venafi platform. We'll navigate back to our DevOps HashiCorp folder, and we want to update our Vault policy. Okay, so if we go to the certificate tab, we want to allow the end users to request certificates from that new domain. So we're just going to allow newdomain.com in our allowed domains list. We'll save that policy, and With the monitor engine, there is one additional step. We do have to actually come down and apply that policy, because when a request is made to Vault CA, the system is evaluating the request based on the policy set forth by Vault. And so if we don't apply the policy that we just made that update to within Venafi, it's still going to be using the old policy that it pulled down from the Venafi platform. So if I run that same command to issue this certificate, we shouldn't see any changes because, again, that policy, it hasn't been applied to the Vault role yet. See, so we still get that same error message. In order to make it work, what we need to do is apply our policy again. Okay? And by doing this, we now see that new domain has been added to our policy. And if I make that same request again, it comes back almost instantly. One of the other benefits to the Vault Monitor integration is the ability for the system to continue fulfilling certificate requests, even if there is no connection to the Venafi platform. So if there's some network latency issue or something else that prevents that connection to Venafi, the Vault engine still has the latest policy, so it's still able to continue issuing certificates. When the connection to the Venafi platform is reestablished, all of the certificates that were issued by Vault will then be uploaded to the Venafi platform to give that security team, again, that visibility that they need. And so to simulate that, what I'm going to do is turn off the SDK endpoint, our API listener. So I'll go and I'm specifically going to stop our web SDK service. And so by doing that, we can just test that everything is not connected. I'm going to try and get a certificate from the PKI backend. So if you remember, this should reach out to Venafi to fulfill this request. But in this example, because our API is currently turned off, we should get an error that we can't reach the API. Okay. And so if we go back to using the Vault Monitor plugin, what I'm able to do is continue making some new requests. So I'm going to do about app 9. And again, we still see the issuance time sub 1 second. And we can start to get a couple more here, just to demonstrate that our queue will fill up. And when the connection, again, is established to Venafi, these certificates will all be uploaded for the visibility of the security team. Let's do 11. Okay. And so if I go and take a look at my Vault issued folder, I'll do a refresh here. We see all of our old apps here, but none of the new ones coming through. And just to demonstrate that one more time, I'll try app 12 here. And keep in mind the venafidemo.com domain as well. Okay, so we see that. We've actually got the certificate, so that can be injected into the pipeline now and used for whatever purpose it's intended to. And if I refresh this folder again, we're not seeing any new certificates come through. This app 11 here is left behind from an old example, so we're not going to worry about it right now. But 9, 10, 11, 12, none of the new certificates that I just requested have made it through yet. And the reason, again, is because there is currently no connection to the Venafi platform, but we're still not able to issue certificates that are out of band. So if I try a different domain, maybe I want to do app 13 for another new domain. Even though the Venafi connection is not currently established, we still get an error and we're still preventing certificates being created that don't conform to the company security policy. All right, and if I now take a look at what we have in the import queue we should see my 4 certificates that were issued that have not been uploaded to the Venafi platform, again, just because that connection's not there. And so if I go back and turn our API listener back on, we should automatically start to see these requests drop off as they're uploaded to the Venafi platform. Okay, so you can see 3 went in that one batch, and if I do it one more time, our import queue is empty. If I refresh this last time here, we see our new certificates that we just requested come through. Thanks for taking some time out of your day to explore how Venafi and Vault can enable InfoSec and DevOps teams to work faster and more securely together while continuing to use the same tools that they do every day. As some key takeaways, I'd like you to remember that together, Venafi and HashiCorp are able to automate the fast provisioning of machine identities in DevOps pipelines. They're able to enforce consistent policy across the entire organization, and they can prevent certificate-based outages through visibility and automation. Ultimately, info security is assured, DevOps is fast, and perhaps most importantly, they're working together to enhance the security of the organization.